we decided to simulate the daylight in the perimeter zone of an office that is facing east and west here in the tropics. And we simulated according to the methodology under LEED and WELL standards. And then also we analyzed it according to how we think is a more realistic way in terms of using the blinds. So the facade perimeter is quite complex. You have the sun coming in, you have heat coming in, but you also want the daylight, but you don't want the glare. So the big unknown in the facade zone is how is the manual blind going to be used, or if you have an automated blind, how will that be operating? So according to LEED, the LEED simulations will often give quite high daylight autonomy because they assume you have an automatic blind. So that means the blind is only activated when you have direct sunlight entering the space. And if more than 2% of your total floor area is hit by direct light, then the blinds come down. So for this particular office, we found that the blinds would be down about 2% of the time across the year. But most offices don't have an automated blind. So if you have a manual blind, then it's unlikely that you will rush to the window and adjust it all the time. So we looked at how often would the blind be down if, let's say, it's not adjusted for 1 week or for 1 month. So there's sort of a long time between the adjustments. So if you only adjust it once a week, then the blind will be down 66% of the time. So that's of course much higher than 2%. And that will of course greatly then affect how much daylight you have in the space and the views out. The other thing that we also found that could be a deficiency of the LEED way of doing it is that they only engage the blind when direct sunlight enters the space. But in the tropics, the sky is very bright and glary with sort of this light cloud cover that gives this very white diffuse light. So a lot of people in this part of the world will actually pull down the blind for glare reasons, just to block the glare from the diffuse sky. So it was quite an interesting comparison where there's a very big difference between what the LEED scenario and what we believe is a more real scenario. The study also looked at 2 different facade types. We had a normal facade where you just have a blind and there's no sort of daylight system apart from that. And we then fitted one of the facades with quite a wide light shelf that can effectively shade the low angle sun. And once we do that, then we see that with the light shelf, we don't have to operate the blind. And we actually have a higher daylight autonomy behind such a facade than one where we have a manual blind, which is left down probably most of the time. So if you don't have the money for an automated blind, then a facade with a light shelf is likely to give you a better daylight environment. But if you have an automated blind, then maybe you can get more daylight from having this automated blind. But it doesn't really account for that additional glare from the diffuse sky, so we need to study that a bit further. And if we look around in Malaysia, we see these office buildings that are quite glazed, and you just see the blinds are basically all down. So there's definitely a mismatch between the LEED simulation that says the blinds will only be down 2% of the time and what we see here in Kuala Lumpur and other tropical cities.